Hi everyone. Last session we did discuss the force. Today we will study together Newton's law of motion. A scientist, the British scientist Sir Isaac Newton, explained the relationship between force and motion with three laws of motion. Newton's first law describes the motion of an object that has a net force of zero. So object at rest. So the law states an object at rest stays at rest and an object in motion stays in motion at the same speed and direction unless it experiences an unbalanced force. So if there is any unbalanced force will be exerted on this object, the object will remain will stay at rest or at the same speed as it is. Okay, let's look at the two parts of the law. First part is the object rest stay at rest, which called the law of inertia. Okay, of inertia. So inertia its main means no movement or tendency of all objects to be at rest. A tendency it is a tendency of all object to resist a change in motion. Okay, so it will stay at rest. An object will not move until a force makes it to move. So a chair will not slide across the floor unless a force pushes the chair. Okay, so if you see this picture, the magician, after pulling um, uh, out the cloth, the all the dishes and cups will remain without movement, will remain in place. So because there is no unbalanced forces exerted on these dishes, it will remain in place. The second part of the first law is an object in motion stays in motion. Now let's look at the second part of the Newton's first law of motion. It states that an object in motion stays in motion at the same speed and direction or velocity unless it experiences also unbalanced force on it. Think about coming to a sudden stop while riding in a car. The car stops because the brakes apply friction to the wheel, making the force acting on the car. This is unbalanced force did on a moving object like the car. So car will keep moving forward until it stops. What about your seat belt? Your seat belt applies an unbalanced force in you also. This force stops you forward motion. Both parts of the law are really stating the same thing. After all, an object at rest has a velocity, its velocity is zero. Okay. What is Newton's second law of motion? So now we have the first motion of law for Newton's, that all objects at rest will remain at rest unless unbalanced force exerted on it, and the same for the moving objects have the same speed and direction will remain as it is, as there is no unbalanced force exerted on it. The second law of motion: when an unbalanced force acts on an object, the object accelerates. Newton's second law describes this motion. The law states The acceleration of an object depends on the mass of object and the force applied. In other words, objects that have different masses will have different acceleration if the same amount of force is used. Try to push your friend. You can push your friend Omar in a distance different than the same push you will do, same force to another friend whose weight is much more than Omar. So you can push your friend and you will see the distance differ in that you did with Omar because different mass are there, but there is equal force exerted on different mass, so the acceleration will be different. So in other words, objects have different masses, will have different acceleration if the same amount of force is used. Imagine pushing a shopping cart. When the cart is empty, you need only small force to accelerate. But if the cart is full of groceries, the same amount of force causes a much smaller acceleration. So what is the equation here? Newton's second law links force, mass, and acceleration. In this formula or equation, force equals mass multiplied by acceleration. When F stands for force, M for mass, and A for acceleration. This equation tells us that a given force applied to a large mass will result in a small acceleration, like the example of your friend. When the same force is applied to a smaller mass, the acceleration will be larger. So here, if this is the formula, force equals mass multiplied by acceleration. So 1 unit force, 1 Newton, equals 1 unit of mass like kilogram. And for the acceleration is meter per second squared. So we can call 1 N, 1 Newton equals 1 kilogram dot or multiplied by 1 meter per second square. Okay, so here in this example, these players train by pushing a massive object. The players push with a force of 150 Newton. You said, Mister, that 1 Newton equals 1 kilogram multiplied by meter per second square. And the object has a mass of 75 kilogram. So what is the object acceleration? We put the equation, force equals mass multiplied by acceleration. Then we will substitute force 150 Newton, which means 150 kilogram dot meter per second square equals 75 kilogram is the mass multiplied by A. So A equals 150 kilogram meter per second square divided by 75 kilogram. Okay, so the final will be, after correction, this will be 2 meter per second square. This is the acceleration. You can do the same here for another example. Once 160 kilogram is the mass, and the force is 150. So what will be the acceleration? So we did discuss right now the Newton's first law, and we're gonna go for the Newton's second law. Okay, we did discuss the first and second law, right? And we go for the Newton's third law. What is the Newton's third law of motion? Newton also devised a third law of motion. The law states whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first one. So when you push against a wall, Newton's law tells you that the wall is actually pushing back against you. Okay, so let us discuss the third law in the coming session. I hope this session was easy to you all. See you and thank you so much.